Hello and welcome to another edition of Paul.com TV. Today we're going to be talking about SSL Strip, and this particular video is actually in conjunction with Paul.com episode 147. So if you'd like to hear the audio where we discuss SSL Strip, other matters such as beer, please go to paul.com and go ahead and get set up so you can receive our previous episodes. Also, we have Paul.com every Thursday from 7 to 9, and you can see that streaming live over Icecast. So what we're going to be talking about today is SSL Strip, which is an excellent tool written by Moxie Marlinspike. Just to give you an idea of some of the capabilities of this tool, it basically allows you to strip SSL. Well, why do we care about that? The reason why we care about that is because if we do things properly as a penetration tester, or even as an evil attacker, you have the capability of interjecting yourself in the middle of an SSL communication stream. Not really in between with SSL, but what it does is it strips off the SSL to the ultimate destination. And this allows you to see all of the traffic in clear texts across your system. So we're going to go through, we're going to set this up to basically do some ARP cache poisoning. We're going to do SSL Strip, and we're going to grab user credentials of a fake user ID and log on. So let's introduce you to some of the characters that we're going to be working with today. Oh, core impacted updates available. That's always a good thing. All right. So the first thing is this is going to be the victim system. As you can see, its IP address is 172.16.30.132. And the gateway on this particular computer system is 172.16.30.2. Those two IP addresses are really important whenever we set up the ARP cache poisoning. The 172.16.30.132 system is going to be the target, and the 172.16.30.2 system is the system that we're going to pretend to be on the network to cause all that traffic to be redirected through us. So let's go ahead and let's do some basic setup for this particular attack. As you can see, now what we're doing is we're echoing 1 into proxysnet IPv4 IP forward. This allows our Linux computer system to in effect act as a router. It allows it to receive communications and then forward them on through. If you do not do this, this will not work because we're trying to forward the traffic through our computer system. We also establish a nifty little IP tables rule that any traffic coming in on port 80 is going to be redirected to port 8080 on our computer system. This is important because we're going to be setting up SSL Strip to listen on port 8080 on our computer system. So we've got two things setting up. One, our Linux computer is set up to forward traffic. And two, it's going to receive any traffic on port 80 and it's going to redirect it to port 8080 where SSL Strip is going to be listening. The final command that we're going to be running for setup before we run SSL Strip is ARP spoof. ARP spoof allows us to send unsolicited ARP responses, and it allows us to, in effect, become any IP address that we want on the local network. So we run this, we do ARP spoof space minus I for the Ethernet adapter that we're going to become, or the interface, and we're going to become not really become, this is what ARP spoof is going to be sending traffic on, ETH0. -T is the target. We're going to be poisoning 172.16.30.132, and the 172.16.30.2 is the gateway system that we're going to try to become in this particular scenario. So we fire up ARP spoof, and ARP spoof immediately starts saying that 172.16.30.2 is at our MAC address. So now the Windows computer system is going to be sending its traffic to the gateway, not to the real gateway, but to us, where we're going to be forwarding. Now, we're going to be firing up SSL Strip. So let me go ahead and do this. So we can do python./SSLstrip.py. -A means that it's going to log all traffic. It's going to log HTTP and HTTPS traffic. And the port that we're going to listen on is going to be port 8080. If you remember, we set up that IP tables rule to redirect traffic coming in on port 80 to 8080 on this computer system. Now I hit enter, and then SSL Strip fires up. And no real, fireworks or anything like that. It just starts, which I think is nice. Now, on the Windows computer system, we're going to see if we can still surf the internet. Well, we can still go to Google. We can still go to paul.com. And we can see that that website works. Excellent. So the paul.com website comes up. The unfortunate thing about paul.com, the main website, is that there's really no HTTPS. So let's find something with HTTPS. So we do a Google search for mail. Usually, mail applications nowadays have some type of SSL encryption. So I go to Gmail, And I'm going to put in a username of paul.com12345. And I'm going to put in a password of password12345 because I'm really not all that creative. I want to put that all in lowercase. PASSWRD12345. So now if you'll notice, whenever I went to log on at Google, it's still HTTP. It doesn't switch me over to HTTPS. Well, Google did in fact switch over to HTTPS. Google did everything right. There's nothing wrong with what Google's doing here. It's just that SSL Strip is intercepting that SSL communication, terminating it, and then it's basically opening up HTTP to my computer system. So that's not very cool. So now we got paul.com12345, and the password is password12345. Then I select sign in, and this account doesn't exist, and do I want Firefox to remember the password? No, not now. And as you see, the username or password you entered is incorrect. However, for demonstration purposes, it worked perfectly. So now with SSL Strip, it's logging the traffic. So what we're going to do is we're going to cat out SSLStrip.log, because that's the default log where it's going to load logs. It's going to load all of its log of all the traffic, and we're going to grab for paul.com12345. And sure enough, we've got a ton of different information here. So if we go through, we can see that we have our paul.com email has been set up right here. Let me highlight it and then zoom in on you guys. The email is paul.com12345, but notice it also captured the password of password12345. So we were able to intercept and grab that traffic off of that stream that was supposed to be encrypted from the guest all the way to the ultimate destination system. So what does this mean to us whenever we're talking about this from security perspective? Well, if you're a penetration tester, man-in-the-middle attacks need to be in your regimen. It needs to be something that you do in your penetration tests. Also, if we're looking at this from a perspective of let's say from security, like we're a security administrator, we're trying to keep our network secure, this really gets to user education. We can do all kinds of wonderful security to try and lock down our systems, lock down our servers, but if the users are not educated into the bad things that can happen to them on the internet, ultimately, you're going to get owned. And, you know, when we're doing user education, many times we can say, well, you should use HTTPS, and you should definitely do that. You should be checking the certificates whenever you get errors. But I think that you need to demonstrate that risk to the users. I think that doing demos in your own environment, showing people that SSL Strip allows you to do this, and this is what can happen, this is what a bad guy can do, is important. Because if you try to treat your users like idiots, they will be idiots. Trust me. But however, if you try to lock your users off from the internet, all of a sudden you're going to have SSH tunnels leaving. It's odd how that works. So it's a user education issue. It's also a major issue, as I said, for penetration testing. Just going through the standard scanning the network, trying to exploit systems, works in a lot of situations, but if we can get creative with what we're seeing on that network, how we can interject ourselves on that network, we're going to have greater success in our penetration tests. So thank you very much. Once again, this is part of Paul.com TV. My name is John Strand, your host for this evening, morning, whenever you're actually listening to this particular video or viewing this particular video. And this is associated with episode 147 of Paul.com Security Weekly. Thank you very much, and you guys have a great day.